Professor Zawolo again today. Today we're going to be going over yet another section of the West African Examination Council Senior Secondary School Mathematics Examination for Liberian schools. Today we're going to be focusing on the subsection trigonometry, and under trigonometry we're going to be focusing on trigonometric identities. So here we'll be applying basic trigonometric identities to prove that certain trigonometrics of expressions are form an identity. So let's go. To do this, we must first go over some basic identities. Now, one of the first set of identities, which is very important for us to know, is called the quotient identities. The quotient because it involves division. For example, it says the tangent of an angle A is equal to the sine of A divided by the cosine of A. And it says that the cotangent of A is equal to the cosine of A divided by the sine of A. That's the first. Then the next set of identities we have will be the reciprocal identities. So which says that the cosecant of an angle is equal to 1 over the sine of the angle. The secant of the angle is equal to 1 over the cosine of the angles. And the cotangent of an angle is basically 1 over the tangent of an angle, forming the reciprocals. Then there are three other very important identities we call the Pythagorean identities. Very important identities. We call these the Pythagorean identities because it involves the application of the Pythagorean theorem. So it says sine squared of an angle plus the cosine square of an angle is equal to 1. The tangent square of an angle plus 1 is equal to the secant square of an angle. And these last two identities can be derived from the first one. So I'm going to just show you how we can derive the tangent square A plus 1 equals the secant, just so that you can understand that you don't need to memorize everything, you just need to do this. So let's go. So if I have sine square A plus cosine square A equals to 1. And I divided everything here by sine square A. So I'm not really changing because I'm dividing every term by the same thing. So my equality is maintained. Well, I'm proving the last one actually. And then divide this by also sine square A. So what sine square divided by sine square is going to be 1. Now cosine over sine is one of those quotient identity. Cosine over sine is basically equal to cotangent. Cotangent square A. And 1 over sine is the cosecant. So I'll have cosecant square A, which we have written over there as cotangent square A plus 1 to be equal to cosecant square A. Well, you can do the same thing to this to derive tangent square A. So in that case, you're going to be dividing by cosine. So this basically shows you some of the identities we need. Now let's go ahead and take on two problems where we'll be applying some of these things. Now, one of the things you must be very careful in establishing the proof is that we're not saying that this is equal to that. No, you need to work with one side to show that it's equal to the other side. You do not accept them as an equation. Manipulate the more complicated side to get the other side that is very simple. So let's begin. What can we possibly do over here to be able to get cosecant square? Well, let's see if we form. So we are taking the left hand side. So I'm going to say left hand side here. So we're going to be taking sine theta over 1 plus cosine theta plus 1 plus cosine theta over sine theta. And so we're going to be adding this. What we will decide to see if we can get the other side. So the first thing, we have a fraction, a rational expressions here. So let's find the least common denominator and see if we can rewrite this. Well, the least common denominator will just be the product of the two denominators, which just doesn't have anything in common. So it'll be sine theta times 1 plus cosine theta. So well, when I take 1 plus cosine theta into here, I'm left with just sine theta times sine theta. I will have sine squared theta plus, now When I put sine over here, I will have 1 plus cosine theta times what? 1 plus cosine theta. Okay, so let's see what we're going to get next. Maybe I'm going to try to use the materials on the side here clearly again. So what am I going to have here is going to be basically it's going to be sine. I'm going to have sine. Okay, so let me just move to the next page. I hope we'll be able to remember what we have here. So, well, let's move on. So what I'm going to have is sine squared theta I'm going to have sine square theta plus 1 plus cosine theta times 1 plus cosine theta over sine theta 1 plus cosine of theta. Now, when I do the multiplication over there, I'm going to have sine squared theta plus 1 plus 2 cosine theta plus cosine square theta over sine square theta. Now, let's see what happens here next. Now, when I do 1, I'm going to rearrange here. I'm going to write sine square theta plus cosine square theta plus 1 plus 2 cosine theta over sine square theta. Now, you can clearly see here that sine square theta plus cosine square theta by the Pythagorean identity is equal to 1. And then 1 plus 1 would be what? 2. So I have 2 plus 2 cosine, and my denominator should have been sine theta. Let me change this. My denominator is actually what I have over there. It's going to be sine theta 1 plus cosine theta. So now I'm going to have 2 cosine theta over sine theta 1 plus cosine theta. Now, I can factor out the 2 from here. I will have 2, then I have 1 plus cosine of theta over sine theta 1 plus cosine of theta. Now you can clearly see that the 1 plus cosine theta will cancel. So I'm going to just put it up here because of lack of space. So what we have now is going to be 2 over sine of theta. I'm going to write this as 2 times 1 over sine of theta. What is 1 over sine of theta? That's going to be cosecant of theta. So basically I have proven here that there's going to be 2 cosecant of theta. So I have shown clearly what we wanted to do. I have 2 cosecant of theta, what we started to prove in the first place. Basically, application of the rule. It gets complicated, it looks hard, but you just apply all of the rules that you know. So we have definitely shown that our identity to be true. So we need to show this, okay? So what we're going to do here, first of all, again, we're going to take the most complicated side, which is the left-hand side, and see how we can rewrite it so that it's going to look like the simple side. So, well, what can we do? What I'm thinking is that I have cosine and sine, and I know that I can rewrite tangent using sine and cosine. So I'm going to take that part. I'm going to take the denominator there, 1 minus tan squared theta, and see how I can manipulate this. Well, this is going to be like 1 minus sine squared theta over cosine squared theta. Now, I have to add fraction. The denominator here is 1. The least common denominator is going to be cosine squared theta. And so 1 into cosine squared theta is going to be cosine squared theta times 1 I'm going to have cosine squared theta. Cosine and cosine will cancel here. 1 times sine squared theta, I'll just have sine squared theta. So now I have changed my denominator to look like this. So if I came now, I can rewrite the situation over here as cosine squared theta minus sine squared theta divided by cosine squared theta minus sine squared theta over what? Cosine squared theta. Now, you understand, this means I'm dividing this by this, so it means I'm multiplying cosine squared theta minus sine squared theta, sine squared theta, not sine of 2 theta. Let me do that again. So I'm going to be doing cosine squared theta minus sine squared theta times cosine squared theta over cosine squared theta minus sine squared theta. So this is going to cancel, and so basically I have just shown you that this entire expression is equivalent to what? Cosine squared what? Theta. Very basic and very simple. What you have to do is to basically go over some of these identities. There are many other identities, but my own investigation research with the WAEC has shown me that most of the other identities, the ones involving the sums of the sums of the angles, the difference of the angles, angle sums formula, angles of the difference formulas, they haven't really shown up on the WAEC test that I've gone over. So just these identities will be sufficient for you, I think. It's always good to learn more if you can. Again, this has been a production of you, the Foundation for Equity and Excellence in Education in Liberia. We are committed to providing quality content education to every Liberian child. We encourage you to watch our videos, subscribe to us, send us your comments, send us your feedback, and also don't forget to subscribe to us on YouTube, follow us on Twitter, like us on Facebook. Also, very important, to make more of these videos available, we need your support. Please contribute to our cause in the cause of education in Liberia. Thank you very much.